This lesson is on solving exponential and logarithmic equations. There are basically three types of equations. The first type is no logs. It's an exponential equation, so we can either use a common base or there's no common base, so we have to use logs. In number two, there's logs on one side, and that is either a common or a natural log. And in number three, there's logs on both sides, and again, it can be a common or a natural log. And in both 2 and 3, we need to make sure we use our properties to combine the logs so that there's only one log either on one side, and then there's a constant on the other side, or in number 3, there's one single log on each side. And we do that by using our properties. So here is our rule. We can use the third log law, which is the power rule or power property, in which we take our exponent and it ends up in front being multiplied by the log, or we can convert between logs and exponents. And that's why we have three different ways to solve this one problem, okay? So the first way says the method of common bases. So in this question, 4 and 8 can be written as the same power. So 4 to the x equals 8 can be rewritten, 4 can be rewritten as 2 squared to the x equals 8 can be rewritten 2 to the third. Now remember, on your calculator you have that factor button, and it will prime factor any number. So that's what we want to do, is get these down into prime factors. So now once we have the same base for common bases, the bases no longer matter. So we only care about these exponents. Those exponents are now equal. So 2x equals 3, divide by 2, so x equals 3 over 2. And I can do a quick check in my calculator and know that I'm correct. Well, not all exponential equations are like bases. So when we proceed, we may not be able to use the method of common bases. We may have to use a log approach. So the first log approach is 4 to the x equals 8. We could take the log of each side. So we could log this side and log this side. Well, using the third log law, this x ends up in front. So it becomes x times log of 4 equals log of 8. Then we can just get x alone by dividing by log of 4. So log of 8 divided by log of 4. And if we put that into our calculator, we get 3/2 or 1.5. Now we could do this log approach exactly the same way with ln if we wanted to. So instead of using common logs, we could use natural logs. Well, guess what? The exact same thing happens. So x equals ln of 8 over ln of 4. Plug that in your calculator, and again, you get 3/2. All right, so when we use the log approach, we can either use common logs or natural logs. And since we're doing the same thing on both sides of the equation, it's good to go. All right, our last approach, which is my most favorite and the one that I use most commonly, is to use this converting. So I have 4 to the x equals 8. Well, that should look familiar. That's Beden form. Base to some exponent equals a number. So what I want to do is take my Beden form and write it in log form. So log of base 4, so log base 4 of 8 equals x. And all I have to do is put that in the calculator to find the exponent. So 4 to what power equals 8, and x equals 3/2 or 1.5. So you can see, hopefully work-wise, why I like that last method the most. So you pick the method that you like, and don't pick common bases because that only works sometimes. So pick whichever method you like, logging both sides, common log, natural log, or writing it in log form. The thing you have to remember about log form is you have to have the base and the exponent alone. That's what you want for all of these, okay? So let's try exercise 2. Well, in exercise 2, right away, I know that 5 and 18 cannot be written as a common base. So I have to pick one of my methods from above, and I'm going to pick the converting to logs method. So right now, this is my Ben form, and I always write it to reinforce, and I have to write it in log form. So log base b of a number equals the exponent. I'm using this from up here. So my base is 5, my number is 18, and my exponent is x. Now all I have to do is plug it into the calculator. So we grab our calculator, we get a calculator page. I'm going to use my log button, which is Control 10 to the x. I'm going to put a 5 in for the base and 18 in for the number. In the first example, when I did log 8 over log 4, I didn't have to put a base in, okay? I could leave this box empty. So my answer to this is 1.8. But the problem is that decimal keeps going. My calculator's in the wrong mode. And how did I get this decimal? I went up on top of 1.8 and hit enter. So I know that I have to go menu, sorry, not menu, I have to go home, number 5, number 2, and I don't want fixed 1. I want it to say float. Make default, and then hit number 4 to go back. So now, if I did that, now I get them all. So it says to round to the nearest hundredth, but my hundredth is a 9 with a 5 after it, so it's x equals 1.80. The next one is a little bit more difficult. First of all, I noticed that the base is e, so I'm going to have natural logs in it at some point. And secondly, I noticed that Ben isn't alone. He's got pieces attached to him. So I have to move this 4, and I have to move the negative 3 in order to get the base and the exponent alone. So first, I add 3. So 4e to the x equals 20. Now I'm going to divide by 4. So e to the x equals 5. And now I'm going to use the same method I used in letter A. I'm going to rewrite it in log form. So log, my base is e of 5 equals x. Now I should remember that log base e is the same as ln. So if I want a different button on the calculator, I can hit ln. Could I plug in log base e? Of course. I'm going to get exactly the same thing. So your ln button is Control e to the x of 5. And then if you hit natural log, you have to put e as your base. And your choice is you hit the e button and put 1 in as the exponent, or you hit the pi button and there's an e without the exponent. And you'll see we get exactly the same answer. So 1.61 is our answer. All right, exercise 3. We are finding the solution, and if necessary, rounding to the nearest hundredth. Well, notice these are not exponential equations, so these are no longer example 1s. We're now into example 2s, logs on one side from the top of the page. So we have common logs and we have natural logs. And if there's more than one, we have to get them together. Well, there's not. There's only one. But again, you want to isolate first. You want to get that log or that exponent alone. So in this first one, I have to get log alone. So I'm going to divide by 3. So now I have log of x plus 4 equals 2. Remember, if there isn't a base, it's 10. I don't have to write it in my work. It's just assumed. So how do you undo a log equation? Well, how did we undo an exponent? We wrote it as a log. So how do you undo a log? You write it as an exponent. So this is log form. So I have to write this in Ben form. So my base is 10, my exponent is 2, and it equals x plus 4. So now I'm going to subtract 4. I'm going to put that all in the calculator, and I get x to equal 96. Now, one of the big things that I haven't been doing, but I assume you are doing, is checking your work. And when we check our work, for the ones where we rounded in exercise 2, they're not going to check appropriately unless we use the irrational decimal. If we use the rounded one, it's going to tell us it's false. So make sure you use the exact decimal. Down here, where we get an exact answer, there's no problem. Just store it and plug it in. But please make sure you're checking. It is very, very important. All right, part B, again, we have to get the natural log alone. So we're going to divide by 1/2. Dividing by 1/2 is the same as multiplying by 2. So I could have just multiplied by 2, which means I don't have any fractions. So ln of 3a plus 7 equals 10. Probably some of you have difficulty with 5 divided by 1/2 as opposed to 5 times 2. Now, how do I write this in Ben form? Well, again, remember ln is the same as log base e. So I have e to the power 10 equals 3a plus 7. Now, e to the 10 is going to be irrational. So e to the 10 is 22,026 point blah, blah, blah. So I need to subtract 7 and then divide by 3. And to the nearest hundredth, a is 7,339.82. All right, that's it for part 1. Continue with part 2.